All right, good morning. Unfortunately, I'm out today, but the nice part is everything we need is in our Unit 2 textbook. So this is going to be a lesson over section 2.2.3 in our Unit 2 textbook. Our learning target is going to be to identify the average rate of change of quadratic function. So we can get our textbooks out and open up to this blank page on page 56. And please write this down. So average rate of change, that's the rate of change between any 2 points. Any 2 points of a function. So our formula for finding rate of change is f of b minus f of a over b minus a for x values of a and b. Remember, this is the same formula as finding slope. You're subtracting your y values on top and subtracting your x values on bottom. Rate of change is synonymous with slope. Okay, so really you're finding the slope between 2 points, and that gives us the rate of change over that interval. So let's do some practice problems with this. So on page 57, example 1, it says calculate the average rate of change for the function f of x equals x squared plus 6x plus 9 between x equals 1 and x equals 3. So they're giving us our two x values. We currently do not have any y values. That'll be our first step, is to find our two ordered pairs by substituting in and evaluating for the x values they gave us. So let's first find f of 3 by putting in 3 for x. So we substitute in 3. So we have 3 squared plus 6 times 3 plus 9. So 9 plus 18 plus 9. And that would give us 36. So our point, or ordered pair, is at 3, 36 for the x value of 3. And then we'll do the same thing, substituting in 1 for x. So f of 1 is 1 squared plus 6 times 1 plus 9. So 1 plus 6 plus 9. So that'd be 16. So now our second order pair is at 1, different color, 1, comma, 16. Now we're going to use our rate of change formula to determine the rate of change between these 2 points. So our 2 points again were 1, comma, 16 and 3, comma, 36. And our formula for rate of change, sometimes you'll see ROC standing for rate of change, is f of b minus f of a all over b minus a. So at this point, this is our x comma y and our x comma y here. So notice there's no real distinction here where we need to use the point 1 comma 16 first in this formula versus 3 comma 36 first, just so we stay consistent across the top and the bottom. Right? If we start with one y value here, we need to start with that x value down here. Okay, so let's plug in our values and simplify. So f of b, 36, minus our other y value, 16. If we did 36 on top first, we'd start with 3 on bottom, minus 1. So this will give us 20 over 2, which is 10. So that'll be our answer of 10. So say the rate of change over, and you'll see brackets used to represent an interval. So rate of change over interval from 1 to 3 is 10. Okay, so let's look at some different contexts we could see this. So this one, they gave us a function and said find the rate of change. This one, they give us a graph. Okay, so this is actually less work because we just need to be able to read a graph to find the correct points that we can use. So it says use the graph of the function to calculate the average rate of change between x being negative 3 and x being -2. Well, let's find our points at -3 and -2, looking at those x values. So at -3, we have a point right here on our function. Looks like that point is at -3, 2. And then here at -2, well, if we look at the way this is labeled on the y-axis, so we went up 4 spots to get up to 2. So if we go down 2, this is really at -1. So our point would be -2, -1. So we have -3, 2, and -2, -1. And these are the 2 points that we're going to find the rate of change for. Remember, rate of change means slope. So what we're really finding is the slope of this line here between the 2 points. Okay, so we can label them as our x's and y's if that's helpful. X, y, x, y. Or subtract the y's on top, x's on bottom. Okay, so we could say the rate of change equals, so we take -1 minus 2 over, if we started with -1 here, for our x, we'd have to start with -2 minus -3. Now we can simplify. Minus a negative down here would become a plus. So something is a plus. -1 minus 2 on top is -3 over -2 plus 3 is 1. -3 over 1, so we get -3. So that'll be our rate of change. Okay. Look at example 3. It says for the function g of x equals this, is the rate of change is the greater between -1 and 0 or 1 and 2? Whoa, this is going to be a lot of work. Okay, because we're going to have to find all these different points, and we have to calculate 2 different rates of change. All right, let's plug in -1 first. So -1 minus 3 squared minus 2. We have -4 squared minus 2. So that'd be 16 minus 2. So 14. So first point, -1, 14. And then we plug in 0, our second value they gave us, right? That's what we're doing right here. So g of 0. 0 minus 3 squared minus 2. -3 squared minus 2 is 9 minus 2 is 7. So 0, 7. So these are our 2 points. Now let's find the rate of change between them. So we could do, for example, 7 minus 14 on top. Over, if we start with 7 here, we have to start with 0 here. 0 minus -1. So I mean -7 over, this is a plus, so this will be 1. So we get -7. Okay, let's do the same thing for the x values of 1 and 2. All right, we're doing this part now. So g of 1, that's 1 minus 3 squared minus 2. -2 squared minus 2. Oops. 4 minus 2 is 2. So this point would be at 1, 2. And then lastly, we have the x value of 2. So g of 2. So it'd be 2 minus 3 squared minus 2. -1 squared minus 2. That's 1 minus 2. That's -1. 2, -1. And now let's calculate our rate of change between these 2 points. So we could do y2 minus y1, right? -1 minus 2 over 2 minus 1. -3 over 1 is -3. Okay, so now we got to draw our conclusion. So when we compare rates of change, we're thinking which one is changing faster. So we're not concerned with the sign. Okay, we're thinking which one is changing faster. So we're comparing -7 to -3. Well, -7 is changing much quicker, right? We're going down 7 units every one, versus over here we're only going down 3 units every one. So -7 is the greater rate of change. So we would say that first interval from -1 to 0. So we could summarize this, say rate of change over -1 to 0 is greater than our second interval, which was 1 to 2. Okay. Last one we need to get through for our notes for today. Example 4, so now we're given a table. We like these problems because we just need to be able to read a table for the correct points. Okay, so x being -0.75, well, that's this ordered pair here. -0.25, this ordered pair right here. And let's find the rate of change between those 2 points. So we can do 8.44, or y, minus our other y, 3.44. If we start with 8.44, we got to start with the matching x value, -0.25 minus a -0.75. On top, that makes 5 over minus a negative becomes a plus. So -0.25 plus 0.75, that'd be 0.5. Okay, and then check this in your calculator if you need to. 5 divided by 0.5, 10. Right, dividing by half is the same as multiplying by 2. So rate of change over that interval would be 10. Okay. All right, so goal for today was be able to find rate of change given a function, given a graph, or giving a table that represented a quadratic function. Homework for tonight in our textbook, we're looking at page 61 to 62, questions 1 through 10.